Guys, this is your last video for the week. We are going to be multiplying decimals. I'm not going to spend as much time on this as long division because we do multiplying in the middle of all of our long division problems. So you have probably been practicing multiplying a lot this week. So there's only a couple small things we do differently when it comes to decimals. And a lot of you I saw in class know this. So I really want to kind of make this a little bit of a shorter video, okay? So our first problem is 0.3 times 0.5. But this is not the way that we're going to do the problem. We are going to actually line this up on the right, okay? Now I know on this, the decimals are in the same position, but that's not necessary. What is necessary is that all your numbers are lined up on the right. So even if it was like this, we would line up on the right. We don't line up at the decimal. Okay, hopefully that makes sense. So now I take my 5 and I multiply it by the 3 and the 0. So 5 times 3 is 15 and I carry that. 5 times 0 is 0 plus 1 is 1. So then when you're done with the number, you cross it out and you leave yourself a placeholder. Now I work with the 0. This next number, whatever that next number is. So 0 times 3 is 0. 0 times 0 is 0. I add, and I don't need a 0 in front of any number. Okay, we know this means 2, but we don't write O2. Okay, so we're not going to even write that. Now, I have a 15. Do you really think 0.3 times 0.5 is 15? No. So what we have to do is account for the decimals. So we're going to literally count them up. I had 1, 2 decimal places. Let me show you again. I had 1 and 2 decimal places. So in my answer, I count in 1, 2 decimal places. So your answer is 0.15. Okay, so you count in your decimals at the end. All right, let's do another one. Let me actually show you something with this one. You don't have to write this down. I just want to show you. I often don't put a 0.3. I put 0.3 and 0.5, and here's why. If I would have done this problem like this, I would have got the same answer without all those zeros you saw at the bottom. So 5 times 3 is 15. It's 1, 2, 1, 2 decimal places. Okay, so that's why we really try to tell you guys that those zeros are not necessary. Yes, I could say 0.15, but 0.15 really does mean the same thing. And when you're doing the math, it avoided an entire line of zeros we absolutely did not need. If that doesn't make sense, go back and watch that last little example one more time and compare it to this. Okay, let's do another problem. So the problem is 3.2 times 2.1, but I'm going to go ahead and just write it like this because there's no reason to write it twice if I don't have to. Times 2.1. So I'm going to multiply the 1 by everything, then I'm going to cross it out and put a 0 as a placeholder, and then I'm going to multiply the 2 by everything, then I'm going to add and count my decimals in. So multiply the 1. 1 by 2, 1 times 3, cross this out, leave yourself a 0. 2 times 2, 2 times 3, then I add, then I count in my decimal places. So there was 1 and 2, so I count in 1 and 2. So my answer is 6.72. Okay, hopefully that makes sense. Let's do another one. Why don't you try this one by pausing the video and see if you can do it on your own. Notice, this is that first one that really doesn't line up at the decimals because it didn't have the same number of decimal places. So what you want to do is line it up to the right. Why don't you pause and try this video? Try this problem. Okay, let me show you the work and let's compare. So I'm going to do 8 times 9, so 72. 8 times 9 again, 72, 73, 74, 75. 9. 8 times 1 plus 7 is 15. Okay, so I cross this out and I leave myself a 0. 3 times 9, 7 with a 2, 27. Again, 3 times 9, 27, 28, 29. Make this a 2. 3 times 1 is 3, 4, 5. I add all my numbers, so 2, 16, 15, 5, 6, 7. And then I count in my decimal places. 1, 2, 3. So 1, 2, 3. So 7.562. Now, we need to ask ourselves, does this answer make sense? Would about 2 times about 4 be about 7.5, 8-ish? Yeah, that would make sense. And then what we can really do is also check with our calculator. So 1.99 times 3.8, and we got 7.562.